So we're going to talk a bit here about Taylor series and how they can be applied into binomial expansion. And so binomial expansion is something you may seen before, you probably have seen before, where we have a pattern for if you have a binomial like x minus 3 raised to some power, how we can expand that really quickly, just like we can FOIL quickly. That's like x plus 3 raised to a power. We have a pattern, we know what it's going to look like. So we're just going to show how Taylor series can be applied to that. And in order for us to do that, we need to make sure we understand what a combination is. So we've got some notation that you'll see, such as these parentheses with a number on the top and a number on the bottom. And what that essentially means is m factorial over m minus k factorial k factorial. So an example of that might be if I had 10 choose 8. This is a combination, and I would read that as 10 choose 8. Then that would be 10 factorial over 2 factorial, 8 factorial, which 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which that part is just 8 factorial. 2 factorials, 2 times 1 are just 2, and then I still have an 8 factorial. So we can see those cancel, end up with 90 over 2, which is 45. So that's the essence of this combination here. And the reason I'm just showing you that is because it shows up in our definition for binomial series. So our binomial series, what we end up with is if I have 1 plus x to the m, essentially what I know is I can write that out as 1 plus the sum from k equals 1 to infinity of m choose k x to the kth. Okay? So what that means for this binomial series is that this is the same, I'm going to write that over there because I need some space, as 1 plus m x over 1 factorial. So that x is to the first power, plus m minus 1 x squared over 2 factorial, plus m minus 1 m minus 2 x cubed over 3 factorial. And this list can continue going on. And when you think about what we had up here, when we had an 8, 10 choose 8, we ended up with that 2 factorial left in the bottom there. Okay, so we had 2 terms left in the top, 10 times 9, and we just had that 2 factorial left. So that's kind of how it works. And let's do an example here. So let us expand. And in this situation, we're expanding 1 minus the quantity 2x raised to the third. So 2x is my x here, right? That's what I'm using as my x from the formula. And the 3 is my m value. So as I list this out, I would end up with 1 plus 3 times negative 2x, that's to the first, over 1 factorial, plus 3, and then I would have a 2 following that, negative 2x squared over 2 factorial, plus 3 times 2 times 1, negative 2x cubed divided by 3 factorial. So simplifying this, I would end up with 1 minus 6x plus 24 over 2x squared plus minus 48 over 6. 3 factorial is 6x cubed, or 1 minus 6x plus 12x squared minus 8x cubed. So this is just similar to that idea of the Taylor polynomial. It kind of shows up in a binomial expansion.